Okay, so now we're going to take a look at scatter plots and finding what we call a correlation coefficient today. And again, we're going to be using DESMOS. So if we're given a table, we can enter our table in like we learned a few days ago. So I'm going to enter this table in right here. We're going to hit the plus sign, add a table, and then I'm going to enter my numbers. So 1, enter, 2, 4, 6, 8, 9, 10. And then our y's are 41, 43, 44, 46, 47, 48, and 49. And then we can move our graph so we can see our points. Now, what I want to point out is when you enter in tables, do you see how it says x sub 1 and y sub 1? If you want to make an equation with this table, you must enter and use x sub 1 and y sub 1 so that it knows to use that table. If I go here and I add another table, see how it became x sub 2 and y sub 2? So it's now changed it because I already have used the sub 1 in the first one. So just keep that in mind. So we don't want another table, but what we want to find today is our correlation coefficient. So a correlation coefficient is a value, and it is an R value, and that R value explains how closely those points are to making a straight line. So if you look at the points plotted here, they do not make a straight line, but they are very, very close to making a straight line. And they are going in the positive direction because it's going up as you go across the graph. So I know that it's a really high positive correlation, and your correlation coefficient will always fall between the numbers -1 and +1. So it's some decimal that falls between those. So to use Desmos to find that, we type in our table, and then the next thing you do is you go to the number 2, and we want to type in really just the equation y equals mx plus b. But because I want it associated with this table right here, instead of just y, I need y sub 1. And instead of just x, I need x sub 1. So to find it, we're going to say y1. And notice how it went down below. I didn't have to do anything. All I did was say y1. I didn't hit spaces or anything. And the next thing you need to do is hit the tilde. So you're going to go shift, and then it's above your tab button, and it's going to give you a tilde. And then we have m, and then x1 plus b. So I just typed that in. And I want to point out, so what it does is it draws your line of best fit here. And if I zoom in, notice it does go through some of the points, but not all of them. And it gives us several values over here. So it tells you what your m is and what your b is. So you would be able to write an equation in y equals mx plus b based on those parameters. But the other thing it tells you is your correlation coefficient, which is your r value, not your r squared. That's your coefficient of determination, and we're not going to be discussing that today. But our R value is 0.9907. So if you remember at the beginning, I said it was really close to making a straight line, but they were not all on a straight line, the points. So because it's in the positive direction, it's going to be really close to a +1. So our R value in this case is 0.9907, which is very close to 1. So if we take a look at, if I make up a different table here, if we get rid of that, and let's just say it was 3, 5, 7, 11, 13. Oh, whoops. And then let's go 6, -1, -13, -5, and 1. Let's just hit the home button, and then I can zoom a little bit. So here are my points. And I want to find my correlation coefficient. So you can see they're kind of spread out. And so if we look and we write y1 tilde mx1 plus b, you can see that our R value is -0.2233. So it's actually really close to negative or to 0, which means there really isn't much correlation going on.